So I just want to compute the average of the first term, or the expectation of the first term. So we want to compute the expectation of this minus, or so let's just do plus. So ord p q double underlined vj, the j squared, like so. Okay, so this is the expectation. The first time we'll do the second average later. Okay, so this is what we want to compute. All right. Okay, so to do this, we need a little lemma. So this is a lemma. Oh, that's gray. That's why. So we need a lemma about so just finite probability spaces. So it says that so if we do the expectation of, let's say, some function of let's say we have a bunch of random variables, and let's just look at the nth component where we average over, so we vary over x1 through xn, right? So it turns out that this is just the same thing as the expectation of a single variable. So the other ones don't influence them. Influence the first part here. That's important here because in this formula, right? So in our application, so we have that here, that E, right, or P, Q double underline, like this, right? So this thing is varying over V0 all the way up to Vj in of places in the distinguished lifts, distinguished places of the field K, sitting above a fixed rational prime P. Okay, so so this is what we have. So now we know that this is here, ord P, Q, just a single one, and it doesn't matter which one it is. And we can write out now the definition of okay, so that's how we got this equality. And now we write down the definition here. And so what does this mean? So this is, we take the field of moduli over QP, so that's the weight that we get, divided by the degree of the field. And so this is for V dividing P. Okay? So, and of course this will be 0 when, we know that it's 0 when it's good. Okay? So this is, so these things will be 0 most of the time. So that's kind of it's kind of an abusive notation, but that's what we mean by this. Okay, and so this is ord P. Oh, so this is a double underline still. Ord P Q double underline V, this to the J squared. Okay, and all right. So. Okay, so let's look at this again. So this is now. So let's write this. So this is equal to 1 over this degree. That's the field of moduli. Then we can split this into the ramification and inertia. So this is the sum. Okay, j plus 1. And oh, sorry, we don't need j plus 1. We got rid of that. So we have inertia. So just inertia v, not v, p, or p, q double underline v to the j squared. So again, the v underlined and v, it's the same thing. And then we have this degree here. Okay, so this becomes here. So this allows us to convert to, let me write it like this, normalized Arachelov degree. And this allows us to convert to the order at V, P, and so this is the order at V of Q double underline V to the J squared here, like so. And then this is just the degree of this place. All right, and so that's our formula. Oop, let me go back. So that's our formula for the first average. Okay, so so this thing here is equal to the expectation of, well, I'm just going to copy it down, minus ord p q double underline this thing j squared, like so. Okay, and now for the second average, so now we can do the second average. So the second average, so here we take this thing to the j squared, like so. So this is the expectation now over j's. So, and we can plug in the first the first result. So this was the Arachelov degree here of this divisor, UP, and then we had, okay, and so I guess this is these are bad here. So we should emphasize that these are bad, because in order for this to make sense, right? So I guess, you can take the convention that this is 1 when it's not there. So this is a ord P or ord V Q double underline V J squared. And we have this divisor like so. So these are bad. Okay, I guess I could have written the bad here. And then by definition, so this is the sum. So this is the average over J. So this is 2 over L minus 1. The sum from J is equal to 1 to L minus 1 divided by 2 of this degree here. Here, like this. Of these things here. Ord V Q double underline V, the J squared, like so, V. Okay, and now we can combine them. So we sum over the primes. And in this one, there's no Archimedean place, so we don't have to worry about anything. So I guess we could call this the expectation over P, right? And there's also a log P. So okay, so this is what we have. Outside of this whole expectation over P, there's a log P. So we'll have that. So the sum. Okay. Okay. So I guess it's not quite the degree here, right? It's not quite the degree here because of I need for this to work, I need a natural log of P here, right? Okay, and then that's the appropriate form. Okay, so let's assume that the natural log of P's have already been absorbed into our statement. Okay, so let's sum over the primes, and now this is the correct form. And so now we have 2 over L minus, sorry. So we have, so now we can pull this out. Let me pull that back. Okay, so we sum over the primes of E P squared of this thing. And this becomes the sum over the primes Okay. Well, it's going to be the 2 over L minus 1 sum of j is equal to 1 L minus 1 over 2. And this thing is this degree here, F0, of the same crap above. Okay? And so you can bring this in. And so this turns out to be the degree, the LGP degree of F0 of the theta pilot object. Okay? And this is what we get. So the conclusion, this is the conclusion, right? So the conclusion is that here, that this is equal to this. Okay? All right.